Okay, good morning, everybody. Welcome to the Molding Casting Week, FabAcademy 2021. I will share my screen. And you're seeing something weird. So this should be our week. As you can see, I'm still busy taking notes from our regional review and from Neil's class. Yeah, you saw the one, Jeff. Oh, is Jeff still here? No, Jeff disappeared. Have you ever tried, like he gave a recommendation, where was it? Neil really likes the microwave radar. And to somebody, he was proposing this this chip that has like 5 Hall sensors in it. I think this could be interesting for Jeff for making the joystick. One day we have to go to Akihabara in Tokyo. I think this must be quite awesome. And yeah, it's somewhere in there. This 5-axis thing for making joysticks with Hall sensors. Or actually, I could just Google Hall. Here. No. Where did I put it? Yeah, never mind. Topic today is. Did I find it? Where are we? Stupid WebEx is always hiding all my tabs. And I have too many tabs, as always. Okay, here we go. Let me just put this in full screen. Okay, can you see my screen? Yeah, perfect. Okay, molding and casting. So this slide is not something that you have to, that we're not going to go through right now. It's just a bunch of links. The first one is to my molding and casting in FabAcademy. I tried to make a planetary gearbox because this is something that is kind of missing. It's still missing, so if somebody wants to make a nice gearbox for a planetary gear, they're very expensive if you buy them. And they're very useful for any type of vehicle that you want to run with a standard DC motor. So I found a model that you can use in OpenSCAD. And I decided to make this piece. Actually, I wanted to make all the pieces, but I ended up just making one. But yeah, a good trick is you can use another text editor. I'm sure Microsoft Visual Code also has some add-ons for OpenSCAD. In this case, it was Sublime Text. And there's a plugin so you can get the autocomplete and all the functions from OpenSCAD inside Sublime Text. And yeah, I'm sure this works for Visual Studio Code as well, which makes it very comfortable to work in OpenSCAD. Yeah, here I'm explaining how to install it. And so I had to adjust the size a little bit because the original one was quite high. And here you have to mill all those little details with a very thin mill. And it's very hard to get a 0.5 millimeter mill that is like 1 centimeter long. So I decreased the height a little bit. And this is the wax that we're using. It wasn't really easy to get it in Lisbon because I couldn't order it from like United States, but I actually found a shop um, in Lisbon that sells this wax. It's the jewelries or the jewelry supply shops that sell this wax, and you can get it in 3 different colors, and each color has different properties. So the green one is the softest one. The this whatever color this is. Oh no, contrary. The green one is the most rigid one. So you get like the crispest details, but it doesn't flex. It will just break. The purple one is the all-purpose one, and the blue one is the most flexible one. And yeah, I've never used any of the others. I always use the blue one, probably because it's Neil's recommendation. And yeah, this stuff is wonderful. You should be very careful to clean your whole working space, your whole milling machine, so that in the end you can collect all your chips and cast them into a new block. Casting the new blocks is not as easy as it sounds. Like I had many failed attempts because you basically need a metallic form to cast it into. If you make it from wood, it will degas and you will have bubbles. If you stir it with a wooden stick, it will make bubbles. If you take aluminum foil and put it into a wooden box, then when it contracts, it will wrinkle the aluminum foil, so you get a very coarse surface. In any case, you have to cool it down very slowly. So you should just leave it in the oven and let it cool down over an hour or two. So you get like a smooth block. It will shrink, so it will retract from the edges. That's the good thing. But yeah, I highly recommend you use this wax. And in the Fab Lab, we have a lot of it. So that's easy. Yeah, so my first task was to divide it into pieces, but I will talk about this in the next slides. There's some good classes on Instructables on molding and casting, but basically they repeat everything that me and Neil are saying. There's a good molding and casting lecture from Saverio. I think he was doing this professionally, so if you want to see what a pro has to say to this topic, you should watch this video. It's like 45 minutes. Yeah, it's also a very good introduction. And there's the infamous guerrilla guide to CNC machining. Neil didn't know this. I was very surprised. But it's really good. And if you go to the starting page, like now I'm in chapter 2 of 8. So it very it goes through all the details, everything you need to know about undercuts or features on the backside, how to measure your runout from your mill, how like he explains many things that you might already know, like conventional and clamp milling. Then there's a list of materials, all the different machines that you can use. It seems that this has been updated. Yeah. So then it tells you about the mills. And so the reach length is a very important, how do you say, measurement, because this is kind of limiting the height of your model that you can have. And in conjunction with the diameter, if your mill is very small, your reach length is going to be small as well. So you can't really have very detailed features at the bottom of your mold. And this is one of the major problems that you will run into, but there's tricks for like getting around this. And I will try to get, here this is the way you would measure the runout. You would need like a proper indicator, like If you have one that measures like tenths of millimeters, that's already good. And people that do this professionally, they use an indicator that measures a micrometer. They're not very expensive, so this is something you should have in your lab. And let me just quickly go all the way to the bottom. No, I don't want to go to chapter 3. I want to go to the very first one, maybe like this. And you can either choose to see this page by page, or you can click here and it will open the whole thing as one long page. And the one thing that I really like, if you go here to remarkably cool and precise designs, you can see some of the pieces that this guy made, and it's just beautiful. So he makes these tiny, tiny little gears in a very similar technique to what we're doing. He's using a material that is called wren shape. It falls into the category of chemical wood. So actually, it's not really wood. It's more like a polyurethane foam with a very dense one. Unfortunately, a block like this is probably 30, 40 euros. And it's one-time use only. So yeah, once you're finished, you either have to mill it flat and make another mold, or you take the backside. But it's a really nice material. Actually, we have a lot of it in the Fab Lab. So if you're interested in trying this, we have like a box with like sample pieces of different types. There's a whole bunch of different chemical woods. If you read the Guerrilla Guide, he references to all of them. But yeah, unfortunately, it's quite expensive. For Vasco, it might be interesting that I forgot the name of the biggest producer of cork in the world. It's a company in Portugal, and they sell a special type of cork for replacing the wren shape. Unfortunately, you have to buy it in quite big pieces. So I think the cheapest one you can buy is like 300 euros, but then you get like a square meter or more. So if you want to do it like Portuguese style, you can make your mold from cork. And then he uses similar silicone than we, and you get a similar mold. He just puts like a thin layer of acrylic on top, which is something that you should do with a lot of, should do very careful, because your pieces might stick to the acrylic. So you should apply a good amount of mold release before doing this. But then he gets these tiny little pieces and he makes a gearbox for one of those mini motors, which is incredibly tiny, but it works very well. And here you can see some more pictures of the stuff you can do. And this is all completely impossible by 3D printing. Like even if you have a printer that works with resin, it's tricky to make pieces this small and this precise. And once you want to do like 20, 30 of them, molding and casting is your way to go. And you can cast transparent materials, and you can get very strong materials also. So this is my favorite video of this tiny little motor running this 3-stage planetary gear. And yeah, this is just beautiful. So if anybody wants to repeat this, would be great. Like I would love to have this gearbox as a mold. So because we have lots of these motors, but they're basically unusable without a gearbox. So this would be a very nice project. And here you see all the other pieces. So he makes this crazy little robot that can flex all the wheels. Here you see another wren shape mold with a very detailed milling, and it's just super tiny. This is the whole robot. And I think he also has a little video of the robot in action, which is this one. And apart from the motors and the screws, this is all molding and casting. So you can actually make, yeah, quite remarkably cool stuff. Even like the little holes and everything all comes straight out of the mold. Okay, so Guerrilla Guide to CNC Machining, in my opinion, it's like a must read. I forgot what this one was. Oh, damn it. Where am I? Ah, yeah, this is another. This is prop making from Tested, like you know the Adam Savage, and and this is another like interesting tutorial. So yeah, there's lots of information on this. So this is the matte wax. It's like 20 euros for a block like this. This is again Guerrilla Guide. And so what type of silicone resin should you use? And Neil really likes the smooth on. I absolutely don't like it. The only good thing about it is that it's not very toxic, but it doesn't last very long. So it degrades very quickly. So after a year, you can throw away your molds. There's other silicones for the same price that last basically infinitely. So, for example, this mold here, um, this is this is a silicone that I bought in Lisbon. So it's almost 10 years old, but it's like new, and it's the same price than the other. Um, Here's another one. You can tell that this bin has been casting a lot of pieces already. It's completely dirty. But even like the small details in the mouth, like this is like just a little flap, which is actually loose. But yeah, even like this, it's still lasting. Okay. Um, so Smooth On is like this shop to buy stuff like this in the United States. If you want to buy this in Europe, I would recommend you the shop in Barcelona. So there's, let me see, um, I bet if I Google for Smooth on Barcelona, can't believe that I forgot the name, but it's called FormX EU. So when I was in Portugal, I bought all my stuff at FormX. Unfortunately, the shipping costs are quite high, so you should make a big order. But they have everything you want to have for molding and casting. You can get the whole smooth on, how do you say it? All the products from smooth on. Um, yeah, if you ever go to Barcelona, you should visit this shop because you can actually touch all the stuff, which is uh, normally a bit more difficult. In Germany, there's a shop, it's called kaupo.de. They also have the complete smooth on program, but they're crazily expensive. So I wouldn't, whoops, I wouldn't buy anything there. Um, because in the meanwhile, I found some better shops. For example, let's look in my links. So if I go to, and this might be interesting. Daniela is not there anymore. Are you still there? Daniela is still there? Yeah. So I go to shopping in my links. Where is it? Einkaufen? Here.
Yeah.
Einkaufen. So Daniele, maybe if you want to pay attention just for a second, I found this very awesome shop. Where's silicone? Here. So it's called DWR Plastics. It's a shop in Great Britain. So you kind of have the problem now with Britain not being EU anymore. This is where Mauricio, my friend in Lisbon, he's a reseller for this company, and the prices are just crazy. Like if I look at general purpose molding rubber. This at Smooth-On, this is at least 30 euros per kilo. And here you get like the half a kilo for 11.40, which is great. Or here 1 kilo for 16 euro. So this is half the price of what you normally pay. And if you buy bigger quantities, it gets cheaper. But bear in mind that this is, it all has like a limited shelf life. So after half a year to a year, you can just throw any leftovers away. But yeah, that's just one of the downsides of molding and casting. And let me get back to my slide. Okay. So there's some things you have to pay attention to. One is the pot life, which means how much time do you have for mixing and preparing your stuff until it starts hardening. That's the pot life. So generally you want a long pot life, because nothing worse than like while you're in preparation of your mold, your pieces, your material gets hard. Like this happens very easily. Like you will think I'm exaggerating, but that's something you really have to, like, you should work with your clock. You should put yourself alarms, so you have like 5 minutes for mixing, and then you have another 5 minutes for pouring it, because and you should prepare everything first. Like you put something on the table so that you don't make a mess, and you will make a mess. Like no matter how cautiously you work, you will always make a mess. So cover your table and have some extra paper towels or something to clean up lying next to you. Have your mixing cups, have your chopsticks for stirring. And also think about, like in the worst case, if you get something in your eye or if it sticks to your fingers, you should have ways of dealing with this. So you either be close to a sink or have an eye shower or something. Yeah, if this happens, then your pieces are lost. But even if you just in the middle you realize, oh, I have to get a scale, and then but somebody else is using it, or you can't find the cable for it, then yeah. So from the moment you start mixing your two components, everything has to go in one stream. So make sure that there's nothing that is going to interrupt you in this time. No visitors coming to the lab, no phone calls coming. So yeah, like it sounds obvious, but this is all stuff you should think about. Yeah, shelf life is, so when you buy this stuff, it tells you what the shelf life is, and it should also have a date on whatever you buy. So if you buy silicones that don't have a date on them, that's sketchy. Like, and you shouldn't buy from shops that don't have a date, because this means that they're selling you their old crap that is already expired. Yeah. And talking about sorry. I'm talking about different ways of getting your material ready. Like since the wax is quite expensive, of course we tried to find cheaper ways of achieving the same. And one of my students in Portugal, he was making a big effort. Like he tried to make this network controlled power plug. And he started making it by laser cutting. He milled his own contactors. And the idea was to, instead of making of cardboard, to make it in molding and casting. But as you can see, those pieces are quite big. So you need a lot of wax for milling them. And buying this from the matte wax would have been far too expensive. So he decided to make his own wax. And here you can see him with a cooking pot. And he's mixing paraffin wax with LDPE plastic bags. So you know that there's the HDPE and the LDPE, the high density and the low density polyethylene. Like the high density ones are the plastic bags that make a sound when you move them. and the LDPE ones are the ones that are smooth, that don't wrinkle so much. And so if you cut the plastic bags in long strips, and this seems to be the best technique, like if you just throw them in there, they will just make a big lump and it won't work. But if you heat the wax and then one by one put the strips of plastic bag in there, they should dissolve and they shouldn't form like you see these white areas. This is more of an accident. But he actually managed to make a whole lot of millable wax. Here you can see it like in its smooth form. And so this came out really nice. But it took him quite a while. And you can see that it's very eager to bubble and to make all kinds of things that you don't want it to do. So this does require a bit of practice. So if you want to do this in 1 week, you will have a very busy week. And oh yeah, he actually went to WAG Society for a visit. And here you see him milling his molds on the big milling machine. And yeah, this would be a beautiful story, but unfortunately, he had an accident doing this. So he was cooking this. So first of all, never cook it on gas. You should, if you want to heat this, you should heat it on an electric heater. And but even with all this caution that he had, at some point the wax caught fire. But luckily, he wasn't stupid enough for pouring water into it or something like this. So he just covered it, and that's the right thing to do. And so you starve it of oxygen, and it will stop burning. Unfortunately, what he didn't know is that if you open it like 5 minutes later, it might still catch fire by itself. So that's what he did, and he had like a big explosion almost. And so he kicked over the cooking pot and it ran over his hand. And he has like grade 2 burns on his hand that he will probably keep for his whole life. So yeah, if you ever set wax on fire, cover it and leave it until it's completely cold. If you open it, it might spontaneously ignite. Okay, so much on that. There's many types of molds that you can make. There's like foldable molds. If you look at the mtm.cba.mit edu page, there's one machine that is casted in cement. And he made a folded mold out of sheet metal. So he folded the sheet metal and then casting cement in there, which is a very nice way. But you could even make it from cardboard or paper. Like even if you make one of those paper models, you could use it for casting stuff in there. But yeah, I wouldn't recommend this for this week because we have the wax, which makes things easier. The good thing about the molding and casting is that all the techniques you learn, you can also use them for injection molding, which is like producing almost all of the commercial plastic pieces. It's another bit more complicated because for injection molding you need a steel form and you have to have draft angles, which in our case is not so important. But yeah, with this assignment you will get like a sneak peek into like industrial production as well. Then there's something, it's called slip casting. It's a technique that people use a lot for making plates and cups and all kinds of decorative things. You make a mold out of gypsum, and the gypsum absorbs humidity very easily. So if you pour some liquid porcelain or clay in there, the gypsum will quickly absorb the liquid on the boundary of your object. So there's going to be a layer growing at the inside wall of your piece. And after a while, you can pour out all the all the porcelain that is still liquid, and then you dry and you can burn it and you can make very beautiful pieces. Actually, I will quickly show you a model by how they call it, nervous system. And they make a cup, which is this one. And I hope that here you can actually watch a video. And this is a beautiful example for slip casting. But it also includes all the techniques that we are using. Let's have a quick skip through the video, but I would recommend you to watch this by yourself afterwards. Let's see if my internet is fast enough. So if you don't know Nervous System, you should definitely check out their Vimeo channel. They make beautiful stuff inspired by nature. Among this coral cup. And if you're lucky, they also show us the algorithm that they're using for generating this shape. So they're all unique, like each cup is a one-off. This is one of the geniuses. She's one of the, like there's a guy and a girl, and they make beautiful stuff.
Computationally generated and handcrafted from
You can also see her necklace, which is also made by computationally growing your stuff.
of nature to generate complex objects. This cup is generated by a process called reaction diffusion. Reaction diffusion was proposed by Alan Turing, who also invented the computer.
So this goes back to Alan Turing. Like, yeah, I won't watch the whole video. Let's just skip through more or less quickly. Yeah, so here you see the mold made out of porcelain, and actually the porcelain mold is made in silicone molds. So for getting this, you need like a silicone mold for making this first, which they don't seem to be showing.
Computer science and biology with those from traditional crafts.
But once you have the mold out of gypsum, you can pour the porcelain, and then once it's hardened at the sides, you can pour the inside out. And after drying for a day, you can take it out, and you have this beautiful cup out of porcelain.
Your support will.
Okay, yeah. If you don't know them, check out Nervous System. They also sell all kinds of jewelry. They have really beautiful stuff. Okay, so this was slip casting. Rotational molding is the one where if you wanna make a big model, you want it to be hollow inside, so you don't have to make it solid from like you don't want to waste like hundreds of euros in the plastic, and you also want it to be lightweight. So basically what you do is like the same that we're doing, but instead of filling the whole mold, you move the mold while your resin is hardening, and it's very similar to the chocolate Santa Clauses. Let's see if this guy is showing us anything useful. Not really. Yeah, so here in the background you see a rotational mold in big. Something went poor. So yeah, so this is like the big scale rotational molding, but of course you can do this also in a lot smaller. And there's been many FabAcademy projects where they actually build this machine for rotational molding. Oh yeah, and you can see like those thingies for like redirecting traffic. I don't know if you saw them. Here you can see them in the corner. Whoop. So those thingies, they're made like this. So they're hollow inside, and the only way to get this is by rotational casting. Blow molding, that's it, another technique. This is also very interesting. You make like if you look at the standard polyethylene PET Coke bottle or water bottle, they start out as like they start as like a maybe 20 millimeter diameter, 5 centimeter height little tube. They already have like the and everything on top. So those are made in injection molding, and then you stick them into a mold that on the inside has the shape of your finished bottle. The whole thing is heated, and then you blow compressed air inside, and the thing will inflate like a balloon and catch the shape of the outer shape of the mold, and that's blow molding. There's a very nice bunch of attempts for blow molding 3D printed pieces. So you can actually make and 3D print your original piece, something like this, and then you stick it in the mold and you inflate it, and then you get like very big pieces. So this is super interesting. There's a girl that has some good videos on this, but yeah, so this is what the original looks like, and this is what your finished bottle looks like, which is kind of funny, you know. And so actually, if you ever put a PET bottle in your dishwasher, it will look like this afterwards. Yeah, that's just for you to know. So if you heat the PET, it goes back to its original shape, which is this small ampule. Gravity casting, like in industrial scale, and if you're casting metal, gravity casting is the one where you just pour your stuff into the mold and that's it. But it's also common to put your pieces into a centrifuge, so they spin very fast, and the centrifugal force will push the stuff into the mold. For metal casting, I once built like a centrifuge. There is a professor in Kleve that has a student that built a centrifuge. So yeah, we should actually go and visit him and check this out. There's also techniques where you use a vacuum. So your mold sits on a valve that sucks air very hard, and mostly you have like a deposit, like a big gas bottle that is evacuated. And once you pour your material, you turn on the vacuum and it sucks everything down. But this is more for like metal casting, because if you have just plastic, you can use the vacuum chamber. Yeah, sand casting and vacuum forming. This is where the molds are made of sand. This is very common for metal casting. And vacuum forming, you know, this vacuum forming machine we have, this is also a nice way for making molds. So this is the game that we're going to play this week, and we're going to make a master. So this is just for like, so we all talk about the same things. So the machined wax is your model or your master, which is positive. And actually you need two of those, one for the front side and one for the back side. And they have these little registration marks, so you can so your silicone mold will fit together. And so you make, in this case, it's a two-sided model. So you make two masters, and in them you cast two molds, and then in the mold you can cast your cast or your copy. Okay, and some more vocabulary. So this is more like in metal casting, there's like, or in injection molding, there's like a long list of vocabulary. But in our case, it's not so important. Like if you go into industrial injection molding, all of this is normed. So there's like this angle has a norm up to the smoothness of this. This little, the pouring basin has like a special shape that is also normed. So sprue and sprue base, this is all something that people have spent decades in improving it. Then there's many times, so this is your casting. And so what connects your sprue to your casting is the runner and the gates. So the runner is just distributing the material and the gates connect to your part. Mostly they're very small so that you have an easy time getting rid of them. And then in metal casting, you also have a riser. This is also not a bad idea if you have a two-sided mold. You should give it a riser as well so that excess air can escape. And you can also tell once your mold is full. Yeah. Then here's some pictures from FabAcademy in Barcelona. This is our ex-supermodel. She wanted to make a copy of her mouth. So we used the flax wax. Neil was mentioning it yesterday as well. Another good thing about flax wax is that you can actually brush it on skin. And I think this was the only time that Alessandra was quiet for a few hours because we brushed the wax onto her mouth. And then we 3D scanned the wax with the Modella tactile scanner. And we got like an incredibly high resolution model of a Brazilian supermodel mouth, which was kind of fun. And we had another student, she was making noses. So she scanned people's noses and made molds from that. And as you can tell, this is actually two-sided. So she cut it into pieces and milled those two pieces separately and then glued them together. This was another project from my Portuguese student, João Leão. And so he was sponsored by EDP, the Portuguese electric company, for participating in the Portuguese championship in surfing. And so they made this piece, which is a surfboard scraper. So on the surfboard, you have this wax, the sax wax, so you don't slip so easily. And sometimes you want to roughen it up or scrape it off. So they made like a sax wax scraper. So you can see the two-sided mold. Turned out really nice. This was my attempt. Yeah, so I highly recommend you some type of model that is rather small. So I'm talking size of a matchbox or maybe 2 or 3 matchboxes. Once it gets bigger, you will have difficulties with finding mills that are long enough because you have to reach all the way down here. And imagine for this one, for milling all those tiny details, you need a mill that is very, very small, and you reach down like 2 centimeters. So that's not very easy to do. What's always fun is like making food molds. So this was a successful chocolate casting. But I warn you, casting chocolate is not easy. You have to temper the chocolate. So maybe cast something easier for testing. But in many of those souvenir shops, you can buy all kinds of symbols and like Darth Vader helmets. Also, if you want to cast transparent ice cubes, that's also not easy. But if you want to try this, let me know. I can give you some tips. So yeah, so if you make a small little model like this, you can cast many copies and paint it and give it different accessories. Like this is like highly recommended. Maybe you remember the model with the cats that Neil showed yesterday. Yeah, this is awesome. And once you have a model that you can make infinite copies, you can go crazy and do all kinds of stuff with it. Those pieces are very similar to what we're doing. In this case, it's plastic injection molding, but the principles are the same. So you have your sprue, which is probably somewhere here. Then you have the runners, which are those, and then the gates, which are these. Actually, you don't really see it, but there's like a tiny little connection that connects your pieces to your part. So yeah, you can easily cast many pieces in one go. But then you have to make sure that that you get the air out and that everything works without creating bubbles. So yeah, I highly recommend something in the size of a chess figure, you know, the Kinderüberraschung, these little toys that you get in this chocolate egg. That's kind of the size that we want to go for. Lego pieces are also a good size. Any type of action figure, like those can get quite big, but you can also get like the smaller ones. Tin soldiers, that's also optimal. Um, for the non-Germans, you might not know what a Gartenzwerg is, but I'm sure you'll have a laugh if you Google for Gartenzwerg. So if you're in Spain, you will know the caganers, how they're called. Like this is a very Catalan thing. I think they're called caganer. Yeah, caganer. So yeah, for some reason, Catalan people have a special relation with shit. So in any souvenir shop, you can find any type of prominent figure taking a shit. So if you want like Lady Gaga taking a shit or or Picasso taking a shit, like this is something you find in any Catalan souvenir shop in masses. And yeah, this is here there's Messi taking a dump. So this is the perfect size and type of model that I would recommend you. Or of course a Gartensberg. Um, Next step is basically before you start modeling, you should have a look at the type of mills you have, because this completely excludes some things that you have to choose your model by the mill that you have. In the Portuguese jewelry shops, you can buy special mills for wax, and those are really nice because they have um, very few flutes. And it's just for milling wax, so you don't need like a carbide end mill for doing this. And those are very cheap, like they're like €1 each or less. And you can also get very thin ones. For my mold, I had to make this part longer, so I ground down this one to be a bit longer. The typical ones that we use in the Fab Lab are like a 3mm like if you can choose one where the shaft diameter is the same than the cutting flutes, because if you have like a thicker shaft, you will bump into something almost for sure. So with this one, you have to be very careful, and you can't mill next to your side walls. You can basically only mill in places where there's no vertical walls or only very short ones. But this combination already allows you to do a wide range of molds. Um, if you have anything longer or thinner, even better. And you could even make your own molds just by dremeling some HSS steel, which should work perfectly. And also if you do your mold in Fusion, you should carefully design your mill in Fusion, give it all the right dimensions. So Fusion will warn you if you bump into the walls. Then here you can see one of the molds that I made, and I made one of the various obvious mistakes while putting those little registration pins. I didn't think about the fact that my 3mm mill won't be able to pass between the pin and the wall. So when I did my roughing, it only roughed around those pins, and I had solid material next to the pin. And then when I did the finishing pass with a very small end mill, um, your CAM program doesn't know that there's some material left. Like here, you can see the same problem. So now if you come with your 1 mm end mill and you do your finishing, it's just gonna bump into this little connection and it's gonna break your mill, which is probably exactly what happened to this guy as well. And here you have another problem, so that it didn't even free the circle. So there's like very big pieces in between. And also for the roughing, don't choose your step down too big, because of course it's going to be faster for the roughing, but then it's going to be a lot slower for the finishing, because with a small end mill, you can't smooth this out without exceeding a lot of force on your little end mill. And yeah, something like this will happen. So make a roughing that is not too rough, or maybe make a roughing in 2 stages where you have like an in-between stage. And then only once you have the material gone in all the places that are necessary, only then go in and do your finishing. And in the best case, design your mold that you don't have like these small distances. So keep a good distance from your mold. And here you can actually see and also look at the preview very carefully and think twice what this means for the next step that you're going to take. So I highly recommend you to model your milling bit and to just move it around a little bit to see if it's going to touch the walls or not. Those walls are slightly inclined. So if you move all the way out, you can see that the angle of this wall is just enough to clear the shaft of this mill. Also look from top. So this is my 3 mm mill, and I can move it all around all my features and see, do I have 3 mm here? Do I have 3 mm here? Do I clear to the side walls? Yeah, so this is gonna cost you a little time in the design phase, but it's gonna save you a lot of time once you start milling. Here's some more examples. So you don't have to make your model out of one piece. You can make it out of several pieces. Actually, this is highly recommendable. This is one of the tutorials from the Instructables page that I linked on the first page. So yeah, so they split up their model into 3 parts, which is just, it's one bomb, but they make it out of 3 pieces. Here you can see the nose that Yanaki made, and you can see the 2 pieces that she milled. And in the end, she glues those together for getting her final mold, which works actually nice with Loctite. And this is one of the pieces that I made. So I also made my own millable wax because I wanted to make sardines, which are quite big, and I didn't have the money for buying so much wax. Here you can see the small sardine where I broke off one of the pins. And from here to there, I already learned that those pins are probably not the best way to register your mold. So I made it the way that Neil recommends it. So I completely relieve one side of the mold so that the other side of the mold fits inside. And this works very well. So I highly recommend this technique. And this was one of my students in Barcelona, and he followed the same principle. So he has like a contour around his part that completely fits one into the other. You can see a lot of flashing here. So he could have put this a little bit closer, but yeah, the main principle is this one. Yeah, so there's many different CAM programs that you could use for modeling and milling your pieces. If you use Fusion, then you already know that there's the manufacturer workbench. In SolidWorks has some special functions just for mold making. It has our own mold making workbench, which makes a lot of things quite easy. I think you can have the same functionality in Fusion. Rhino with RhinoCam is also a good combination. FreeCAD with the path module is great. And I would really like to get more into this. Maybe you saw the videos from Christianis in the lab in Finland. Like he made a few tutorials about the path module, and according to him, it's already perfectly usable. You could also use Blender with Fab modules or with mods or Moi 3D or OpenSCAD or Tinkercad. So you're quite free to use whatever you want. If you buy a machine like the Modella SRM20 or the MDX40 or the SRM20, you get a free software which is called either Modella Player or SRM Player, which is a CAM program for exactly what we're doing. I kind of like it. So yeah, and this is maybe the easiest way to make your CAM if you're not used to Fusion yet. So yeah, I also highly recommend you to try different stuff. If you do everything always in Fusion, you're not going to learn about the other software. So yeah, maybe give mods a try or the SRM player. And this is a little video I made as an example for how this whole process can look like. And you will see that this video is like in 8 minutes, I make everything you need for starting to mill. So in theory, you could almost finish your assignment today. In this example, I'm choosing a little Lego piece. So I just download myself a JPEG from Google and save it in the background of my Blender file. And I will skip ahead a little bit so I don't bore you with this. If I find a way of skipping here. Unfortunately, those shortcuts don't work when I'm in PowerPoint. So I put the image in the background. I start with my cube. I adjust my cube to fit my Lego piece. Then I add a cylinder for the legs. I Boolean this together. I make the hands again by making an inner and an outer cylinder and subtracting one from the other. And the head is just a little, how do you say, a spin. So I rotate the outline for getting the head, and I cut out the hands. And this again, like before making this hand, you should know very well how deep your 3mm end mill can go, because this has a certain height. And if your mill bumps to the sides, you will lose your model. And also for making this cutout in between the legs, this cutout is exactly the size of my mill. Because if it was any thinner, my mill just wouldn't get in between the legs. So yeah, you should do very careful planning before finishing your model. And let me see. Yeah, at this point, I'm designing the mill. So you just saw this little piece lying in there. And I'm checking the distance to the sides, and I'm checking the distance to the model. I cut it in half and put one half in each side of a little chamfered box. And I think in the next step, I'm going to put them together again because I forgot to put the registration marks. I think in this case, I'm just putting pins, but yeah. So half spheres or anything else. And you can see me like going around with my little mill just for checking if it's in the right position. And yeah, so I have to move it forth and back and check and and then I cut the spheres on one side and I add them on the other side. But yeah, as I said, it's the better solution is to have the two mold halves register just by having a contour that is going up on one side and going down on the other. And yeah, so now I finished my two molds. I'm adding or cutting the little spheres, and I end up with my two pieces. And this should be mostly it. So export the STL file. Oh, looks like I'm actually showing you how to make the part in Fab modules as well. In Fab modules, you have to pay good attention to your scaling factor. So double check if the size of your model is right. And then you can just use the presets for form rough cut and form finish cut. And it will, yeah, generate you the toolpaths. And let's see, this is what the finishing looks like. And seems that I did something wrong, so I'm correcting something. I don't know what it was. But there's all kinds of stuff that can happen. You might have some inverted normals. Ah, yeah, you see that the head did look, it was just one color. And I think the problem was that I didn't recalculate the normals, so I have to export it again. And the head is still in one color, so something's wrong. Or is it? Yeah, it's still wrong, so I have to go back again and do the whole thing again. Yeah, and now you can see the head is right. And now I get like a proper preview. And yeah, Fab modules take a while to calculate. And I'm also checking the height. So here you can see I'm measuring the distance from the bottom up. This is on one hand for knowing the right length of your milling bit. And you should also have like a centimeter of space from the top of your model to the top of your mold. And just for being rigid enough, if you put this all the way up, your mold is just going to be very flexible. And another thing that you should take into consideration is when you vacuum your silicone is going to grow. So if you can make this even higher, and then you don't fill your mold completely with silicone, but you have some extra space for your silicone to expand. This was me trying to save money, and I cut my block into two pieces, one for myself, one for my colleague. And then I wanted to make like 3 pieces out of each, but it's really tough to cut this stuff in half. I luckily managed and got like 3 nice pieces. Now that we have like a bandsaw, it's going to be a bit easier. But this is also something you should treat this material as precious. It's expensive. Then there's different ways of attaching your wax in the machine. This guy or girl just glued it with hot glue. Now we have in our Fab Lab, we have a very nice way of fixturing. We could either put the vise in there, or I made some little adjustment pins that we could use. Or you just screw it down because now we have a lot of screw holes as well. So this was my procedure for getting from the very roughing to an intermediate roughing and then the finishing. So I went in 3 steps, which I would recommend depending on the amount of detail. Like if you have a very simple model, you might go directly from roughing to finishing, but sometimes it makes sense to have some intermediate steps. And then like if your machine doesn't have end stops, you're kind of doomed because once anything goes wrong, you can basically throw away your model and start from scratch. If you do have end stops, you should write down your zero. So you will probably zero your machine somewhere in a corner, and then it starts milling. And write down the absolute coordinates of your zero. You can also leave like a little mark at the place where you put your zero. So in case anything goes wrong, you can re-zero your machine at hopefully the exact same spot. If this goes wrong, then stuff like this happens. So those lines are the zero bumping the machine and it was a bit higher or a bit lower. So it seems that they had to re-zero twice. Oh yeah, this is the little bomb. So yeah, take good care with like remembering your zero. Write it down on a piece of paper. Ah yeah, so once you reach this stage, you want to know how much silicone you have to mix. One good trick is you pour some grain or some, in this case, they have like little styrofoam balls. You could also use any type of pourable stuff. Of course, you can use water, but then you have to dry your mold, which since we have compressed air, this is quite easy. So I would actually recommend you to use water, and you can just measure the weight of your water, and this should be the same density than your silicone. But yeah, measure your volume and write it down. Okay? Mixing containers. So this is something that many people don't take serious, and then they start mixing their stuff in like a crappy yogurt cup or something. Your mixing container should be something solid. If it's something that breaks halfway through your mixing process, you're gonna have, yeah, you can throw away silicone for like 30 euros. So make sure that whatever you mix your ingredients in is something that is that doesn't break. I really like using I like to reuse the ice cream boxes. So now you have a good a good excuse for buying a big box of ice cream and then using the container for mixing your silicone. You can also use those Tupperware containers, but they're kind of expensive and they won't be usable for food anymore. And in our Fab Lab, we have these super cheap vacuum formed mixing cups. Those are nice, but yeah, it's not easy to find cheap mixing containers. So either recycle ice cream boxes or invest into some cheap, like you can reuse them many times. So yeah, so before you use something flimsy, spend the euro on getting like a proper container. And here you see me using 3 cups. Why would you think am I using 3 cups, and why do you think that I cut them on the top? Okay, Vasco is silent, Harley also, Daniele probably knows. I'm using 3 cups, so I can pour those 2 into the third one. So I have the 2 layers side by side. Because if you put them one on top of each other, then this whole technique that Neil explained with the shearing won't work anymore. You have to somehow scoop it in order to mix the 2 liquids, but then you will get air bubbles in, and yeah, then you're doomed again. So maybe you remember that Neil showed this video where he talks about the shearing and not stirring. It mostly works with two containers and pouring one into the other, but this is only recommended if you have a vacuum chamber. And this is the reason why I cut the top of these cups so that they fit into my vacuum chamber, because I only had like a very improvised vacuum chamber made from like a glass dish and a cutting board. If you look on my FabAcademy, if you don't have a vacuum press, then you should have a quick look at my page. I used the compressor from the laser, and this already made things a lot better. Like here in Camp Lindford, we have a 10,000 euro vacuum chamber, so we don't really need this. And also what I really recommend for mixing is chopsticks. This is cheap and you can, like, I already have a big collection in the Fab Lab. I don't like those wooden spatulas because they might break. Or you can't really mix it as strongly or scrape the walls properly because they are just too flimsy. So I really recommend chopsticks. Since they're out of wood, you might get some crazy reactions with some of the silicones. And this is why you should always make a small test first. So I highly recommend you, before pouring stuff into your final mold, just make a small test piece. It can't be too small, because if the amount of resins you're mixing is too small, it's you don't reach the critical mass for starting this exothermic reaction. So you need like at least a cubic centimeter or two in order to be enough. Yes, you're going to waste like a few euros on material, but this is very helpful for making sure that you don't have any reaction with your mixing chopsticks, that it doesn't stick to your material or it doesn't stick to your mold. So in the end, you kind of save money by making a first coupon, how Neil calls them, and I think I'm reaching the end. So another thing is the pouring. So Neil recommends to pour in one side of your mold, also to incline your mold so that it, especially if you have a double-sided mold, if you just fill it bottom to top, you're gonna have a lot of air trapped up here. So you should either have like little holes where the air can escape, or you can also incline your mold that it fills up at an angle so that the air bubbles can get out. There's this theory that if you pour in a very thin stream, like this, and that the air bubbles will get stretched so much that they will pop. But from my experience, this doesn't work very well, because the thinner your stream is, the more little wrinkles you will generate at the place where it hits the ground, and this will generate bubbles again. So my recommendation is to take your mold together with a cup and just pour it like you would pour a Weissbier. Like you want to have laminar flow, and you don't want to like start like pouring stuff all over your mold. You want to pour from one spot and keep pouring on the same side. Here you can see the person like moving the point, but I would recommend you to just stay on one side and incline your mold so that it like fills up from one side to the next. Here you can see Saverio, like he makes himself, like if you have like a big of material, it's a very good idea to make yourself some smaller cups for measuring and also for pouring, because with this thing you won't be able to pour properly. And here you can see the next problem. Once you start pouring, like it's not gonna pour down the way you expected it. So take into consideration that the container you pour from might do stuff like this, where it drips at the wrong side of your mold. And please, 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 please keep all the rims of the silicone and of the resins clean. Like if this is all full of like the crap that ran over it, the next person using the same container is gonna have a lot of trouble. It's sticky and it's poisonous, so yeah, do everybody a favor and keep everything clean. And I think, yeah, so this was my first attempt, full of bubbles, and then a second pour with a vacuum, and then it came out perfectly. Oh yeah, so this was my little improvised vacuum chamber in Lisbon. This works with a glass dish from the Chinese, a cutting board where I milled a groove so I could pour some silicone in, and I'm just using the compressor from the laser. So if you invert in and out, you can use it for sucking vacuum. Of course, it's better like this pump you see down here. If you Google for two-stage vacuum pump, you will find some machines very similar to this one. They're quite cheap. There's a one-stage and a two-stage variant. you should definitely get the 2-stage one. You can buy it in conjunction with a special cooking pot for degassing. But you could also make it a lot cheaper just by using another pot. Like I bought this huge. Actually, let me show you for a second. Okay, maybe I'll just quickly finish the presentation and then stop sharing my screen, and I can show you the stuff that I bought. But yeah, this is the stuff you can buy. This is a very nice video that shows you the silicone is mostly it's good to vacuum it, but then there's for the casting resin, many times it's a good idea to put high pressure. And so he compares like high pressure to vacuum. Like if you put high pressure, your bubbles just get very small until they become invisible. So yeah, many times it's a good idea to have high pressure for casting the resin and low pressure for casting the vacuum, the silicone. Yeah. So yeah, your silicone will expand when you vacuum it. So you should make sure that there's some space for the silicone to go once it's expanding. So here you can see the person made like a little paper thing around it. It would be better to include this in your wax piece, but yeah, since the wax is expensive, this might not be the best idea. You could also cut a little wooden frame that goes around, but you don't want your silicone to run out when you're vacuuming it. And here you see another idea that Neil also mentioned. You can also just brush on your silicone, and this way you can make sure that there's no bubbles at the surface. So you just put very little, then you vacuum it, and then you fill it up and just let it dry. No need to vacuum it again, because bubbles that are not on the surface of your mold, we don't care. We just care about the bubbles on the surface. So actually, it's a very good idea to just brush a thin layer first, vacuum it quickly, go back and pour the rest. But this is, again, one of those situations where you can easily run out of time. So if you take too much time for doing this, then your silicone will harden in your container. And yeah, it's a marathon. Yeah, and you should also make sure that your mold is kind of level. So before you start working, find yourself some spot in your workshop that is more or less horizontal, because if you put it on an inclined surface, all your silicone will run to one side and you won't have a level mold. And even if it's just a few millimeters, believe me, it's a good idea to level your mold. And yeah, here's some more pictures. Like I had some students in Barcelona or in Valdaura, and they actually wanted to make the rubber part. So they were not interested in making the rubber part was already their final piece. So they made a two-sided mold, but there's no way the silicone will just flow in there and fill the whole mold, because it's just far too viscous for like filling such a thin area. So what they ended up doing is attaching pneumatic fittings to both sides of the mold and putting one side into the silicone and then sucking a vacuum on the other side. So the vacuum will pull up all your silicone, fill your mold, and then drop into like what I would call like a gate. So this one just prevents the silicone from going back into your vacuum pump. So this is actually a quite clever technique. We have lots of vacuum fittings. So if you're interested in something like this, let me know. So what could possibly go wrong? So one of the worst mistakes is that you didn't mix your silicone properly, which will result in a sticky mess inside your master wax mold, which means that you have to start from scratch. Like unhardened silicone in your master is just the worst that can happen. So be very, very careful to mix your silicone properly. If not, you lose a day. If you have resin that reacts weirdly with your mold or that doesn't harden properly, then you will destroy your mold. So you have to start again by making the silicone mold, which is also quite annoying. Then you might have reactions between the mold release and your silicone or your plastic, where suddenly it stops curing. So common thing is like you put a little bit of plasticine just for separating one part from the other. Funnily, plasticine reacts very weirdly with silicone, so it just stops curing. So like whichever material you're going to use, if it's like hot glue or wax or plasticine, make sure that there's no funny reactions with your casting part. What's also very bad is a leaking mold. So especially if you have like two-sided molds, it might easily happen that your mold leaks somewhere. So all of your resin runs out on one side and you're left with a like half empty mold. And mold master doesn't fill completely. Yeah, that's probably part of the leaking mold or part of like trapping air bubbles so that your resin doesn't get everywhere. And this is what this would look like. So this was Yanni. Maybe you've seen him. He's in Finland, and he made a casing for his programmer. And for some reason, he forgot to put the mold release. So this was his finished casted part, but he had to cut it out of the silicone because the two somehow united. This was one of my casts where it still didn't have the vacuum, so it's so full of bubbles that I could break it easily. This is what a mold looks like when you have trapped air bubbles, so it doesn't fill completely. I don't know what went wrong here, but this seems like it developed heat or it started melting some pieces. I don't know, but yeah, there are many things that you probably won't even think of. But once you make like a little coupon, you can rule out all those problems. I think this might be Daniela's molding and casting, and you can see again air bubble problems. And this is the type of mistake where your silicone started hardening while you were still pouring. So yeah, you can tell that this didn't go so well. And I think we're slowly getting to the end. This was again my example with the master, the mold, and the piece. And in the end, I managed to make it without bubbles, and it turned out really nicely. So very happy with this one. I think this was the second attempt of Yanni, where he made another programmer that this time it went well. And this is just a little spacer so that the PCB lies inside the mold properly. Oh yeah, anything that you have inside your mold is gonna want to swim up. So whatever whatever piece you put into silicone or into casting resin, make sure that it can't move. Even if you put some force on it, it should be there solidly. This is another nice example for a coupon, which is this you can finish today. But if you make some copies, you can make beautiful stuff just with like a mold that you made in like 5 minutes. So I really recommend you to make a little coupon like this one. And these are my chocolate sardines that in the end came out quite nicely as well. You can tell that my wax wasn't wasn't so good. So it started leaving a smear behind the milling bit because it's not as good as the commercial wax. And here you can see some examples for two-sided molds. So you need, yeah. So here you can see in the two halves, like this piece has a slight angle in the middle. This was, I think, an idea of somebody making picture frames. So he invented this piece that he wanted to make a lot of copies, and it's impossible to get silicone into these small holes. So I ended up drilling a small hole in the middle that goes through up to the other side, so that your air can escape. If not, you're going to have a lot of trouble getting silicone into small cavities like this one. Here you can see the concept of the outer frame again. So those two fit nicely together. And this is the finished piece. Here's another example for a two-sided mold. So once your parting line gets three-dimensional, it gets a bit of a brain twister. So if you're doing this the first time, you're going to be cursing a lot. I think this was one of my students in Barcelona, and he was cursing so much until he finally got this mold ready. But in the end, it worked very nicely, and yeah, he did some beautiful parts. Yeah, some little cheats. So one cheat is using the hot air pistol, for example, for drying your mold, or also if your surface is not completely smooth after the milling, you can cheat a little bit just by melting it very carefully so that it gets nice and rounded. Or the trick where I told you that you can just brush on some silicone. And another good trick is if you have like little bubbles on the surface, you can use the hot air gun for popping those bubbles. So you just like go over it very quickly and all those surface bubbles will pop. Here's some more examples for two-sided molds. In this case, it's a mold that wasn't CNC machined, but you can just use a finished part. You embed it into silicone, and then people usually cut it open in this wavy pattern on the outside, which is going to be your registration. We have a beautiful example for this in the Fab Lab of casting this Lego piece. And you can see the wavy line on the side. So this is very nicely done. And then you cut the last piece by just spreading it open and cutting up to your part. And yeah, some more examples, pieces that were copied, maybe from 3D prints. So this is the video from Tested. And I think that's it. A last example for doing a rotational casting. So I think this is, oh man, what was the name of this movie? So this thing is hollow in the middle, and you can make it by putting it into this rotational caster. Yeah, I think that's the last slide. And I will stop sharing my screen and I will show you my self-made vacuum chamber. So I bought this pressure cooker, and since it's made out of aluminum, it's quite cheap. Like if you buy like a stainless steel pressure cooker in this size, you will pay hundreds of euros. If you can get one of aluminum like this one, it's 30 euros, a lot cheaper. You will have to invest some money for some proper 20 millimeter acrylic. And this is because this is your window to see what's going on inside. Of course, you could do it without the window, but it's nice being able to look inside. And then I just cut some rubber discs, and I make a little fitting so I can attach my vacuum, and then you can just put this on top of your container. You could even use just like a glass jar and put this on top and vacuum like this. But vacuum explosions are quite spectacular. I don't want you like use a good container. Like once I tried just with a very sturdy plastic container, it was like a waste basket. it exploded that my parents came down from the second floor asking if everything's all right. Like it really goes room and yeah. So I have one small one for like smaller jars, and I have one big one um for the big pot. And just this acrylic is probably going to be like 60 euros. Like acrylic is expensive. So, but this is a good one-time investment. And then you have a very cheap, nice vacuum chamber. Um, yeah, I made another investment. I can show you if I manage to lift it. So this is the vacuum pump I bought. It weighs about 30 kilos. It's a fucking monster. Um, so I bought it secondhand for 400 euros. Oh, it's dripping oil on me. Great. Um, where does this come from? Okay. Um, but yeah, it's nice to have a good vacuum pump. You can get a cheap one on eBay for a lot less, but if you're interested in this topic, you might use this for a longer time, then I would recommend you to invest into something better. You could even build yourself a vacuum pump from just inverting a bicycle pump and putting a valve at the right point. So you pump by hand. You can also find instructions on the internet, people using PVC pipes with their self-made plunger, and you pump like on a big pump. This also works beautifully, and it's a lot cheaper. So there's no excuse for not using a vacuum chamber because you can easily build one yourself. I've seen all kinds of crazy vacuum chambers made from what do you call beer barrels, like a lying beer barrel, or from using in Portugal, it's very common to have those gas bottles, and you can get an old gas bottle for quite cheap. If you evacuate it and fill it with water very carefully, you can cut it open and use this as a vacuum chamber. Yeah, so there's all kinds of workarounds for making yourself a vacuum chamber. Of course, you could do the whole assignment without a vacuum chamber, but you're not going to be very satisfied with the results, because no vacuum means bubbles. Neil kind of pretends that he can do this without the vacuum, but from my experience, like no vacuum, lots of bubbles. Okay, I think this is mostly it. Yeah, if you go to, let me share my screen again. So if you go to our wiki page, I find it. So documentation, FabAcademy 2021, molding and casting. You can see all the beautiful work from last week. Then here, there's the link to the slides I just showed you. Here, I'm going to put the video from that we are just recording. And here's the link to the YouTube video where I show the mold making in Blender and Fab modules. And you can also have a look at the pages from last year. And in last year, molding and casting was week 15. And yeah, maybe you get some inspiration. There was some beautiful stuff. This is done in the next week. So here's some more links from class and from last year. And I bet if I go to the next page, you can see the results from the regional last year. And there was some really nice stuff. One very impressive one is this one, where they did a casting where they casted little hairs from a lotus flower, 10 nanometers in diameter. So yeah, so much on resolution. I once made a cast where I got a fingerprint onto the wax, and you could see the fingerprint in the final mold. So yeah, be aware that you can do crazy resolutions with this technique. Yeah. Okay. Any questions from your side? No? Then I guess we call it a day. And if you need anything, you can just Bashko, did you write anything? Just a second. Okay, how many students? How many Portugals? I had was it 4? Bashko? Yeah, I think I had 4 students. Yeah. We're talking about the Caganeres. So modeling casting is challenging. Yes, scary, but nice. I don't know what FBVP means. Wait, I'm not going to do the practical part again. Oh, okay. Yeah, do the cut part, generate your G code. But you could perfectly do this on your small milling machine. You just have to be careful that you don't lose the 0 because you don't have end stops. And you should have the right milling bits. And I don't know how easy it is to get the materials in Aveiro. If you were in Lisbon, I could give you some advice. But yeah. Oh yeah, and one thing that I almost forgot, I will publish my recipe for this stuff here. So this is a mixture of glycerine and gelatin, which makes a beautiful silicone material that you can reuse very quickly. Like if I put this in the microwave, in 2 minutes, it's going to be liquid. I can make a cast, and in half an hour in the fridge, I have another mold that I can cast, which is nice because you can practice. Like if your first mold didn't come out well, you have a new mold an hour later. So this is very nice. Another little trick that I wanted to show you, like I just recently casted all my leftover wax pieces. Like a long time ago, I made this. We wanted to make the Mexican sugar skulls for the Dia de los Muertos. And so I made this mold. And since then, I have casted thousands of copies. One material that I also like using is this one. So this is just regular silicone from the hardware store. You know, the one that you buy in these tubes. It's like €3 for 330 grams. And if you mix it by weight with 1/3 of cornstarch, maizena, you get a material that smells very bad. It's very difficult to mix. And but if you wet your fingers and you put some detergent, you can actually touch it, and it hardens in half an hour. Like it's really quick. And this mold has already casted like hundreds of pieces, and it's still nice and flexible. And you can see that it's like if you look at my finger, you can tell like I have to really push for flexing this, but it's flexible enough for demolding it easily. If you buy food safe silicone, this gets a lot more expensive, but I found a way where I just brush on the silicone and then I use a heat gun so it dries quicker. So this is like probably 5 to 10 layers of brush on silicone, which is nice if you want to save some money. This is like very flexible, but it still works. I still casted like a skull in this. And so if you don't use the white silicone, you can use any color of silicone. This is another mold for a little elephant made with the same technique. And Yeah, and then you can cast copies like this one. It's an ashtray out of wax, which is completely useless. Or you can make like a little lion like this one. And this one was just done in a mold that is very simple. It's also the brush-on technique. So I didn't even make a mold for this. I just 3D printed a little lion and then brushed on some silicone. So yeah, but yeah, for Neil, we have to 3D mill a mold. It's not okay to just copy a piece, and we have to make a silicone positive and a resin negative. But the resin negative, of course, can be from gypsum or from chocolate or from any other material that you might want to cast. Wax is very easy. Yeah. So if you want to make some awesome candles, like this is actually a candle now, that's a very easy way to go, and also a very cheap way to go, because you can buy a kilo of paraffin wax for like a few euros. It's very cheap. Okay. Tuesday. Okay, Vasco, I wish you a good move.
Hello?
Yeah?
No, it's working. Good.
Ah, okay. Awesome.
There was a crazy problem here. I don't know. It said the mic wasn't working.
Ah, shit. So you're
It's
moving this
it's not fun, but well.
Tuesday?
Sorry?
You're moving to Lisbon on Tuesday?
Yes, finally.
Nice.
I,
Yeah.
I still need to do a COVID test because they are requiring it
Yeah.
at the Polytechnical.
Yeah, infection rate in Portugal is still double of the one that we have here.
No,
It is.
it's very low.
Let me show you. So I go to this page. Maybe I'll stop the recording. Stop.